So if, for instance, you were going to have a combo, and in your combo that you type in for your lunch pin is 5257 or whatever, is it going to work if you type in 7525? No, because the order matters on that kind of a thing. So sometimes the order matters, and sometimes it doesn't. Well, there's two words you just learned, permutation and combination. The P one, that's the kind the order matters. Please write order above the P. 3P2. So what the heck would that mean? That would mean you have three things, and you're going to pick out two of them, and the order matters. All right, there are three kids right over there. You three. Do you get if I grab two of you, just two of you, then there's a bunch of ways to do that. I could pick you two, I could pick you two, I could pick you two. There's a lot of ways to do that, okay? Now, when would the order ever matter? Well, what if it was the first place prize winner gets like $1,000 and second place only gets like $50? Well, then obviously the order matters. If you're first place, you win a lot. In the Olympics, do you get, it's kind of sad, but the gold winner gets almost all the attention. The silver winner, which is like so close, like just incredibly close to as good, that person gets very little attention compared to the gold medal winners. So it matters when you're in a competition. First and second matter a lot. How about vice president and president? Yeah, matters. You definitely would rather be president. All right, so if the order matters, you use the P. So let's do this example. Let's say that there's a book about zebras, so put a Z. Let's write a Z. A book about aardvarks, put an A. And a book about cobras, put a C. If I pull out of those three books, I pull out two of them, does it feel like with books that the order matters? Well, it kind of does. It kind of does. Because if I'm arranging the books on the shelf and I say I'm putting zebras here and aardvarks here, isn't that different from aardvarks here and zebras there? Well, it's different. It just depends on if you care about the order or not. There's no doubt it's different. It's just, do you care about the order? If you don't care about the order, then it's a C problem. All right, some things about the P and the C that you have to understand. Which one does order matter on? The P. All right. Next, where is the bigger number always? The first one is always the bigger number. They can both be the same number, and then it doesn't matter. If they're the same, it's the same. Who cares? But if there's a bigger and a smaller number, the big number goes here. All right. Now, let's talk about how this could matter in the real world. Let's say that these are three kids, Zach, Andy, and Colette. And they are in a competition. They do a thumb wrestling competition at a camp. It's just for fun. And I don't know if you've ever thumb wrestled with somebody. It's kind of fun. So anyway, and you have first place and second place. Tell me why that would have to be a P. Because the order matters. Yeah. First place is better than second place. First place won. Yay. What if I just say, hey, Zach and Andy, could you come over here and help me move this desk? Does it matter what order I call them up in? No, they're just going to help me move a desk. So sometimes the order matters. Use P. Sometimes the order doesn't matter. Use C. All right, next big picture thing is this. What if I have three places for them to stand? Zach, Andy, and Colette. Is it different if it's Zach, Andy, Colette than Colette, Andy, Zach? Is it different? Yeah. The question is just, do you care if the order matters? In some situations, you care. Have you heard of something called a batting order? Yeah. So if you're in baseball or softball, and whoever bats first, that's different than batting second. And usually the person who bats first is better than the person who bats second. Although it's kind of like, if you're really good at baseball, you might understand. Your first batter might be just really good at getting on base. Even if they're not a strong hitter, but they're really good at getting on base. Whatever it takes, they're smart about taking walks and whatever, but they get on base more than the other guys. All right, so moral of the story, does the order matter or not? All right, so if the order matters, you use a P. But you can also do blanks where you multiply the numbers. So pay attention to this. If you're doing a P problem where the order does matter, you can also do it with blanks like this. If I was just grabbing these three people, how many choices do I have for the first place? If this is the batting order, that first place batter, how many choices do I have? Well, there's only three of them, so there's choices of three. But why does it not make sense to just go like this? You have three choices for this, and three choices for this, and three choices for that. Yeah?
Because you have to put one person in the spot.
Yep, so let's say that you have picked this person. Now how many choices do you have for this spot? Two. And then this one's one. All right. So these blanks, they're really powerful. You're going to use them on your test for sure. Sometimes you have to use blanks. What if I said, hey, you get to pick the batting order, you guys, but Colette has to go first? Well, then how many choices? I feel like I should put a C here, but no, it's how many choices. Oh, man. Cell phone goes in the backpack. Put it away. Come on. Gotta pay attention. All right, so the C is Colette. Why can't I just put a C here? Because it's choices. I only have one choice if Colette has to be first. Then it's 1. You put a 1 there. But how many choices do I have for the second spot then? 2 choices for that. And then weirdly down to 1 again. Because I had 2 people left. Colette has to be here. There was 2 choices, though, about who could have been here. It could have been Andy or it could have been Zach. But then I've picked one. Now there's down to only 1 left. Do you get how that works? Let's see if you get how that works. I'm going to give you a new problem. And you can either use blanks or you can set it up with a P. All right? Either way would work. But sometimes the blanks is way easier to understand. All right. So, in this scenario, we have 8 books. And we're obviously picking out 3. That's why there's 3 blanks. If I keep it super simple, it would just be like this. I got 8 books. How many different ways can I arrange them on these 3 spots? I'm only picking 3 books. How many different arrangements could there be? And it would be fair for you to say, does the order matter of the books? And the answer is yeah. It matters what order they're in. So if it's the book about cobras and then zebras and then aardvarks, that's different than if the aardvarks and the zebras were switched. The order matters. Now I know some of you are like, didn't you say to use a P? Sure, you can use a P. And it would be 8P what? 3. Could you use blanks? Yes. And you get the same answer. Let's show you that. How many choices do I have for the first book? 8. How many for the second book?
7.
And then the last book?
6.
Yeah. All right. If you take a calculator, I will do 8 times 7 times 6. Anybody can do that. That's easy. Do you know how to do this? I want to see right now, before I teach you, how many already learned how to put in 8P3 on the calculator? Hint, the math button was the key. I know some people can. My question is, how many people can? So everybody take a second and type in 8P3 on your calculator. If you have no clue, it's okay. This is a poll right now just to see how many of you already know it. If you can all do it, awesome. I won't waste time. How many of you knew how to do it with a P? Raise your hand if you did. All right, that's about a third of you. All right, so those that didn't know, now use your calculator with me. Hit the math button. It says math on it, and it's on the left side underneath the alpha button. There's a math button. Once you hit that math button, I want you to do the arrows. You know, the arrow key, until you get to PROB. On the older calculators, it's PRB. stands for probability. Once you get there, you're looking for the one that's got a P like this. It's the second thing down, and it says NPR on the screen. Find that, and then unfortunately, there's two kinds of calculators. Even with these TIs, they're all TIs. The old version of the software, you had to type, if I want 8P3, you'd have to type the 8 here and the 3 here. And the NPR is in the middle. If you have the new kind of calculator, it puts a box here, and then you put an 8 and a 3 like that. So if you have the old kind, it looks like this. If you got the new kind, it looks like that. But either way, the answer came out to 300 and something. Raise your hand if you've already got it. Awesome. Take a second. I'm going to walk around. I want to see how many people have got this. On their calculator, it'd be easy to copy the number from the kid next to you. I want to see on the calculator that you figured out 8P3. Okay, I'm going to pause for a second. If you're struggling, please ask the kid next to you before I even get there so that it saves time. Okay, so I got it so that everybody now is good at doing stuff like 8P3. And the answer was like, was it 336? Is that right? Is that what it came up to? Okay, good. Let's make sure you understand what it means. There's 336 different ways that you could rearrange those books. There was 8 books, and we were pulling out 3 of them. And there would be 336 ways to do it. That's crazy. It's such a big number. All right. So let's do one more. I'm going to tell you a story. You figure out if it's like 8P2 or if it's like 6C3 or whatever. All right. Here's the story. In this row right here, there is 1, 2, 3, 4, 5 kids. Do you get I could pick random 2 of them? If they were just going to help me because I've fallen down and I need the help getting up, which happened to me. If I was picking 2 out of the 5 of them, judge from what I said if you think order matters or not, and then figure out the answer to how many different ways could I do that. Take a second, figure it out. There's 5 of them, picking 2 of them to help me get up off the floor. It's kind of weird because last week my neighbor called me and he's like, my wife fell out of the bed and I can't get her up off the floor. Help, can you come over and help? And then it was like literally within a week I was on the floor and couldn't get up. But anyway, his wife is really old and she had fallen out of the bed and she's still in the hospital getting like help because falling when you're old is really tough. So anyway. All right, so 2 of you guys helped me get up out of, there was 5 of you, and then 5, did the order matter? No, because I don't care what order you're in, I just want 2 people. 5C2, raise your hand if you had 5C2, awesome. And you know how to put that in the calculator by now, right? Just type it in, and that wouldn't be too hard. Could I have done it with blanks? No. You do it with blanks if you have choices and they're like permutations where the order matters. All right, here's another one. You're going to set up a 5 password to get into your safe. Your dad gives you you and your brother have been stealing each other's crap, and so he's like, I'm sick of this stuff. I'm giving you a safe. You each are going to have your own safe. Set the combo, and then the other kid can't steal your crap. All right? So, or you go to a hotel, they have safes, and you can set the combo. Let's say that there's 10 different numbers that you could pick for each spot. And you might think, the number 10? No. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 spots. 10 numbers. Okay? How many different combos could you pick? If the last number has to be a 1. I know you were going to do it. It was going to be easy. You were going to pick like 10 times 10 times 10 times 10. And then all of a sudden you can't do that, right? Because the last number has to be a 1. So think, how many choices do you have then? How many choices do you have then? For that last number?
1.
1. It has to be a 1. So there's one choice. 10 times 10 times 10 times 1. That's how many different combos there would be if the last number has to be 1. What if you want to make your life simple and you want it to begin with the 1 and end with the 1? Well, then this isn't 10 anymore. What would it be at the beginning? 1. Do you get how that would have only one choice for the first number and one choice for the last number, but 10 choices for all the other numbers? Okay. One more thing. What if the first number has to be 1, last number has to be 1, and the other numbers can't ever be repeats? Like you could never have 993 because like you can't repeat them. So the question you should ask yourself is, how many choices do I have? And it's not 10, because it can't repeat this number and it can't repeat that number. But wait, those numbers were only 1s, right? So if this is a 1 and this is a 1 and I can't have any repeats, do you get that there'd be 9 choices left for that number? And if it can't be any repeats, oh, it's so tempting to put a 9 here, but why is that wrong? It's not 9. It's 8. Why? Because he can't repeat this number either. And then you just multiply your choices. And then that's just 1 times 9 times 8 times 1, which is really just 9 times 8, so it's 72. There's 72 different combos you could have that way. All right. This is a true story. My wedding, there were 4 people that stood up with me for the guy side, okay, the groomsmen. All right, so if there's 4 people, then there were 2 of them that were super tall. So if we're going to take a picture, do you get that you might want to put the tall people like on the middle or on the outside? But you don't want to like make it every other one because it'll just kind of look goofy, like up, down, up, down. They were really tall, 6'5". And then the other 2 of us were normal height. All right. So if I'm going to put them in the middle, then I only have certain choices. Out of the 4 people, 2 are tall. And we want them in the middle. Do your choice thing. Give it a shot. Actually multiply it out. Check with the kid next to you. Ask yourself, how many choices do I have for this spot? How many choices do I have for this spot? And if you're like, could the same person stand in the same spot next to each other? That doesn't make any sense. There's only one of them. One of the people's name that was really tall was Dave. Well, he can't stand here and there. He can only stand in one of the 2 spots. Can't stand next to himself. All right. Did you start with there were 2 tall people and I got to pick one of the 2 tall people? And now once I picked one, there's only one left? How many of you did that part right? Awesome. Now, it's tempting to put 4 here, but it can't because there aren't 4 people left. It's 2 people left that were like the normal height people. And then there's only 1 spot left here, and there's only 1 person left. So you only have 1 choice for that. Final answer, there's 4 different ways we could have arranged the picture. 2 times 2 times 1 times 1. All right, so that's called permutations and combinations, and sometimes there's blanks, which help you figure out how many ways to do it. All right, now you will be way better at being able to answer the homework questions from the first 2 days. One of them was called permutations, one was called combinations. The calculator can do some of them, but some of them you have to use blanks and multiply them. Now, I want to help you with one of them, and some of you guys may want to redo it because I never do this. But I'm setting these 2 homework assignments that were Schoology quizzes. I'm setting them to be, you get the highest score, and you can see the answers from your previous attempts. Okay, so in other words, if you retake it, you're pretty much guaranteed to get 100%. So, if you didn't do so hot on it, or you never finished it, now, today, for the rest of the hour, I'd like you to work on those 2. The only other thing we had was things called tree diagrams. If you had a 65% chance of getting a heads because you have a weighted coin, it would go like this. And that's generally how they look. And then to get like the probability of a heads and then a tails, you follow that and then you go, I just multiply them together. And so I go 0.65 times 0.35, and that's 0.225 to get heads. Tails, it's a 0.2275 probability. About 22% chance that I'd get a heads and a tails in that situation. All right, hold that thought a second. So, what's your job for the next rest of the hour, which is like a half hour? Is to go look at the last 2 homework assignments. And actually there was 3, but do the ones called permutations and combinations and do the Schoology quiz over again if you didn't do so hot on it the first time. Those of you that did it already the first time and did it well, awesome. I'm very proud of you. I looked. There was several of you that did that. But there was also a bunch that did it and it really sucked. And there's others that never did it, which I get it. You were probably just lost. Now you're smarter than you were. Please take a minute and go back and work on those at this time. That's your only homework, is to finish up the old homeworks for the last 3 days.